Good afternoon. This is the relearning for standard NLG.b.1-3, analyzing gravity and analyzing proportional relationships. You should have your worksheet out. If you need a copy, there is an extra one that will be posted on Hapara. The first thing we need to start with is, what are the questions you need to ask yourself as you solve a proportional problem? So here are the 5 questions. If you could write them down on your relearning worksheet. The first thing we need to do is figure out what 2 quantities are we looking at. Are we looking at distance and gravity, or mass and distance, or what are we looking at? Then you need to think, what is the proportional relationship between those 2 amounts? Are they directly proportional, or are they proportional by the inverse square? The third thing you need to figure out is, how much change has happened? Has the distance doubled? Has the mass tripled? What's happened? Once you've done that, you should solve for the amount of change in the other quantity. Now, the last step is only if you're solving for an exact amount, and that's if you need to multiply the change in the second quantity. So say the weight has doubled, then you need to multiply that too by the original weight. So go ahead and write that down. If you need to pause the video at this point, go ahead and do that so you have those all written down. We're going to do some practice problems and go use these steps. So I'm going to switch to the dot cam here. And so just a couple of reminders, if you want to write this down. Underline quantities or amounts, and circle change. So let's look at number 6 with this idea. So if the mass doubles, what happens to the gravity? So I'm looking at mass and gravity, and I'm going to circle it's double. My first step, again, was making sure I knew which quantities. I'm looking at mass and gravity. From my memorization of facts, I know that mass and gravity are directly proportional. I'm going to just make a quick note myself. The third step is, if we go back and look, the third step is how much change has happened, which is, if you flip back, it's doubled. That's the amount of change that's happening. And then number 4 is solve for the change for the other quantity. Well, if they're directly proportional and the mass has doubled, that means the gravity has also doubled, or doubles. Okay? Number 7, if the mass of the planet is 1/2 the mass of Earth, how does its gravity compare? Again, we're looking at mass and gravity. We need to know the proportional relationship. Mass and gravity are directly proportional. The third step is how much change has happened. Well, it didn't change, but we're in our comparison, it's 1/2 of the mass. And then the fourth step is to solve. And if it's directly proportional, if the mass has been cut in half, the gravity is 1/2, or times 1/2. Number 8, if the mass of a person as they grow from a baby to a teenager grows by 5 times as much, what will happen to their weight? So we've got 5 times as much weight. Mass and weight are directly proportional. How much change has happened? The mass has grown by 5 times. And that means that its weight is also times 5 of the original weight. A baby is born on Earth and weighs 35 newtons. In 2 years, its mass doubles. What is its new weight? So really here, I circled this, but this isn't really the amount of change. So I'm going to go ahead and erase that. If it helps, you can put a box around original amounts. So let's go back to our steps again. Which two amounts are you looking at? Mass, weight. So you're looking at mass and weight. Those are directly proportional. The mass has doubled, so it's times 2. Now we're going to use step number 5 for the first time on this worksheet. And we have to multiply the change. So multiply the change in the second quantity by the original weight. So then we know that the weight has to have doubled. So we need to multiply 2, or doubling, by the original. So we're going to multiply 35 newtons times 2, which equals 70 newtons. All right. Let's flip to the back. Number 10, this is our last just simple mass and gravity problem. Planet in a newly discovered universe has 4 times the mass of Earth. If Earth's acceleration caused by gravity is 9.8 meters per second squared, that's our original amount. What is the acceleration of gravity on the newly discovered planet? So first, I'm looking at mass and acceleration caused by gravity. From my memorization of my facts, I know that they are directly proportional. Step 3, how much change has occurred? The has 4 times the mass. And then step 4, so we need to figure out how much change will happen. So the acceleration of gravity will be 4 times as much, but that's not our final problem. The final problem is, what is the acceleration of gravity on the newly discovered planet? And so we actually need to do step 5, multiply the change in gravity by the original gravity. So I'm going to just go over here, do some longhand math. 4 times 8 is 32. 4 times 9 is 36, plus 3, 39.2. And I need to put a unit on. Okay. So my final answer is 39.2 meters per second squared. Again, the more practice you do with those steps, and if you annotate, as I suggested, it'll really organize your thoughts rather than just being overwhelmed by the words. Number 11, if the distance between two objects doubles, what happens to the gravity between them? So again, we're looking first, what two quantities are we looking at? We're looking at distance and gravity. Second, what's their proportional relationship? I'm going to write inverse square, but I'm going to abbreviate it like that. Number 3, how much change has occurred? Well, it's doubled. Step number 4 is solving, and so we can't just say times 2 now. We have to take times 2 is what happened to the distance, so we have to take the inverse of that, which is 1/2, and then we have to square it. And 1/2 times 1/2 is equal to 1/4. All right. Number 12, if a meteor is coming towards Earth and the distance is 1/10 of what it was in January, how does the current gravity compare to the gravity in January? Again, first step, what are we looking at? We're looking at distance and gravity. Second step, how much change, or excuse me, second step is what's the relationship, inverse square. Third step, how much change has occurred. Fourth step, solve this. So we got to again take the inverse. The inverse of 1/10 is 10. Squared is 10 times 10, which equals 100. So the current gravity, if the distance is 1/10 of what it used to be, the current gravity would be 100 times as much. If 2. Now, be careful. One thing I saw a lot of people do is as soon as they saw a number, they circled it. We're talking about 2 stars. You do not need to circle the number. 2 stars are 4 times as far away as they used to be. How does their new gravity compared to the old gravity? Well, the only thing I underline is gravity. So there must be a different amount in here. And if we look at it as far away, it doesn't really specifically say it, but as far away is really talking distance. So what we're two amounts are not spelled out as they are sometimes. So we gotta be careful. So that we're looking at distance and gravity. What's the proportional relationship between distance and gravity? They are proportional by the inverse square. Step 3, how much change has occurred is change 4 times. Solve. We need to take the reciprocal and square it, which equals 1 times 1, which is 1, 4 times 4, which is 1/16. So their new gravity is 1/16 of what it used to be. Last but not least, if an object has a weight of 10 newtons on Earth and is transported to a planet with 1/2 the radius, what is its new weight? So object is a weight of 10 newtons, 1/2 the radius, what's its new weight? So we're looking at radius and weights. They are proportional by the inverse square. The radius has been cut in half. We take the inverse when you square it, which equals 4. But we're not done. We have to figure out, we have to take the original amount and multiply it by the amount of change. 4 times 10 newtons equals 40 newtons. So the new weight is 40 newtons. All right, so the rest of it, you need to practice on your own. Just a reminder, when you look at this table, all of this information, if you look at this problem, we did not know the exact radius. You do not need to know the exact radius. You do not need these columns of this table. The only column you're concerned about is this. This is the acceleration of gravity. All right, good luck, and please turn that in to me as soon as you can. Thank you, and have a great day.